Okay guys, so in this lecture we'll be doing the practice of finding the meso compound out of the given structures. So let's start. So the question is um, find meso compound. Okay, so you have something like this: CS3 OHH OHH CS3. So um, in this case uh, it won't be a meso compound. Why? Because it is uh, chiral, but it is not having any plane of symmetry. Okay, second example is HCl CS3 Cl CS3. Okay, so in this compound, whether it's a meso compound or not, yes, it's a meso compound. How? Because we can see that CS3 is having symmetry across CS2 group. I beg your pardon, this is CS2. So across CS2 you can see that there is a plane of symmetry. Let us look at this example. Here we have CS3 HCl. Okay, let's look at some more interesting problem first, then we'll come back to this later. Okay, so we have something like this. So this is above the plane and this is below the plane. So it is having surely a plane of symmetry like this. So symmetry or plane of symmetry is there, but there is no chiral center here. Is it the right thing to say that there is no chiral center here? So what we can actually say is it obviously means whether it is right to say it has the chiral center or not. That's the question. So I suppose your answer is it does not have a chiral center, but howsoever it will show geometrical isomerism. So because of the presence of cyclobutane ring, but it does not have chiral center. Why? Because from this carbon, if you go anti-clockwise or clockwise, you will have the same set of groups. So two groups are same, hence does not have chiral center, hence it is not a meso compound. Okay, so it is not a meso compound. Let us look at some another example. We have here CS3 CS3H and CS3H and another CS3 here. Okay, so we have something like this. So is this a meso compound or not? So it's not a meso compound. Why? Because this is not chiral. Okay, so let's have a look at this compound. We have HCl here, and similarly we have H and Cl here. So is this a meso compound? So if you look, it's obviously chiral. Why? Because at this carbon and this carbon have chirality. They have asymmetric groups around these two carbons. So it is obviously chiral, And does it have plane of symmetry? Yes, it does have plane of symmetry here. So plane of symmetry is also there, hence this is a meso compound. Okay, let's look at some more examples. So is this a chiral compound, meso compound? Yes, this is a meso compound. Why? There is a plane of symmetry. And is there any chiral center here? Yes, this is the chiral center, this is the chiral center, so chiral center is also there. Let's look at this example. Here we have Cl, Cl and H here. Similarly, we have Cl and H here. So does it have any plane of symmetry? No, it does not have any plane of symmetry, hence this is not a meso compound. Okay, so now the next set of questions is you have to determine how many planes of symmetry the organic compound has. Okay, so total number of POS. Okay, so we have this compound. So how many total number of planes of symmetry it has? It has two planes of symmetry. One is the horizontal plane and another would be this plane. So 2 would be the answer here. How many planes of symmetry are there for this compound? So again the answer would be 2. Why? One is the horizontal plane and another is this plane. Let's look at this. How many planes of symmetry this compound will have? So this will have 1. Second is the horizontal plane and third would be this plane. So total 3. Let us look at this compound. We have CS3 and CS3 here. So how many planes of symmetry it has? If we calculate, we will have 1, 2, 3 and 4 is the horizontal plane. So total 4. How many planes of symmetry will this compound have? HCl and okay, CLH and HCl. So how many planes of symmetry does this compound have? If we look at the perpendicular plane, means passing through this carbon atom and this carbon atom and bisecting the ring into 2, so it will equally divide the chlorine and carbon atom, chlorine, hydrogen and this carbon atom into 2 halves, hence one plane of symmetry is there. Okay, so let us look at 6th example. How many planes of symmetry are there in CH4? So in CH4, if you look at the tetrahedral structure, it would be something like this. Okay, let me make it again. It would be something like this. Here. So in a tetrahedral, how many planes of symmetry are there? As you can see, we can have a plane of symmetry starting from passing through each of the faces of the tetrahedron. So how many faces of a tetrahedral are there? I suppose 4 are these faces. So let's suppose this is a tetrahedral centered around here. So 1 2 3 4 are the faces, plus we can also have from the center of the tetrahedral. We can also dissect from the center of the tetrahedral, plus we can also dissect from a plane which passes from the center of the tetrahedral and is horizontal to the base of the tetrahedral. Okay, so total 6 is the number of planes. So I hope you get this. Okay, so the 7th example is, how many planes are there which dissect this? So the correct answer would be 3. How? From the chlorine atom, 1 can pass in a tetrahedral. Okay, and we have 3 remaining hydrogens. So from the 3, 2 planes can be passing, which actually dissect. So suppose this was the structure. This is hydrogen, hydrogen, and hydrogen. So one plane can be passing from this 2 hydrogens, and another plane can be passing from these 2 hydrogens. Okay. So yeah. So how many number of planes of symmetry we have for this? So I hope you can imagine this structure. This bond and this bond are going into the air, and this bond is actually going into the plane. Okay. So how many planes of symmetry are there for this compound? First would be cutting all the faces from the mid part. So this would be one plane of symmetry. How many more? So one can be parallel to this plane. Okay, one can be parallel to this plane, and the last can be parallel to this plane. This plane, the carbon atom which is in the air plane, the plane which is parallel to the in air carbon atoms, and one plane which is parallel to the last chain which is going inside into the plane. Okay, so total 4 number of POS is possible for this compound. Okay, so in the next lecture we will be talking about another type of symmetry in an organic compound, and that would be center of symmetry. Okay, so till then, good luck and goodbye.